All right, so let's get started on this one. This question says, write the standard form of the equation of a circle described below. The circle will have a center of 0, 5, passing through the point negative 5, 4. So let's start by writing out what standard form is. Standard form of a circle is going to be x minus h squared plus y minus k squared equals r squared. The h and the k as an ordered pair is the center of the circle, and r is the radius. So we are given the center of the circle, so we do know the h and the k that will substitute into the standard form. And I'm hoping that with this information here, that the circle passes through the point negative 5, 4, that we're going to be able to figure out the radius of the circle. So what we have to remember is the definition of the radius. The radius is the distance between the center and any point on the circle. So if we can calculate the distance between the center and the point, we'll be able to find the radius. We do have a formula for distance between 2 points, and that formula is x2 minus x1 squared plus y2 minus y1 squared. We're going to substitute the 0, 5. I'm going to label these. It doesn't matter which one you choose, but I'm going to let one of them be x1, y1, and the other be x2, y2. We're going to substitute them into the distance formula, and that will give us the distance, which is the radius. So y2 is, we're going to do x2 first. x2 is negative 5, minus x1 is 0. y2 is 4, minus 5, it's y1 squared. We're going to simplify following order of operations. We do what's inside the parentheses first. Negative 5 minus 0 is negative 5. 4 minus 5 is negative 1. Negative 5 squared, that will be 25. Negative 1 squared is 1. We have square root of 26 is our radius. And then we have enough information to substitute all the parts into the standard form. So now into our standard form, which is x minus h squared plus y minus k squared equals r squared. We'll substitute the h of 0, the k of 5, the radius is square root of 26, and we'll simplify. X minus 0 squared is just x squared, y minus 5 squared, square root and square cancel each other out, and you get 26. So we have x squared plus y minus 5 squared equaling 26. And we have that standard form of the equation of a circle with center of 0, 5, passing through the point negative 5, 4. Okay, so let's take a look at this example. In this example, we want to evaluate the function f of y equals 2y minus 9 at the indicated values. In part A, we want to find f of y plus 3, and in part B, we want to find f of y plus h. So our given function is f of y equals 2y minus 9, and in part A, we want to find f of y plus 3. So what we have inside the parentheses is our placeholder for the variable. So what we want to do is replace that y with the y plus 3. So this would give us 2 times y plus 3 minus 9. And we can simplify using the distributive property. That would give 2y plus 6 minus 9. And then we can combine the like terms. 6 minus 9 would be negative 3. So we get 2y minus 3. But then we can do part B, which is f of y plus h. And we're going to do the same thing. We're going to change what's in the parentheses with what we have that y. So that would give us 2 times y plus h minus 9. We can use the distributive property on the 2. That's 2y plus 2h minus 9. This time we don't have any like terms, so we've got it in its simplest form there. So f of y plus h is 2y plus 2h minus 9. So on this one, we want to find the x-intercepts and the y-intercepts of the function. And our function is f of x equals 10x squared minus 2x minus 3. Now, I like to start finding the y-intercept because it's typically a little bit easier. So to find a y-intercept, we're going to let x equal 0. So we're going to substitute a 0 into our function. F of 0 is 10 times 0 squared minus 2 times 0 minus 3. 0 squared is 0 times 10 is 0. 2 times 0 is 0. And 0 minus 0 minus 3 is a negative 3. So we have a y-intercept at the point 0, negative 3. So then we want to find our x-intercept. So to find an x-intercept, we let y equal 0. Our equation doesn't have a y, but it does have an f of x, and f of x is the same thing as y. So we're going to set f of x equal to 0. So that would give us the equation 0 equals 10x squared minus 2x minus 3. Now this equation is a quadratic equation because of the squared. And there are several methods for solving quadratic equations, like factoring, the square root method, completing the square, and the quadratic formula. Factoring and the square root method are nice and simple methods. However, they don't work all the time. The quadratic formula and completing the square are methods that could solve any quadratic equation. So what I typically do when I'm solving a quadratic equation is I will try to factor first. And if I'm not able to factor, then I go to the quadratic formula. So I try one of the methods that are more simple first. And then if I'm not able to do that, then I go to the method that's reliable, that can work all the time, which is the quadratic formula. So I'm going to try to factor this. And when you factor, there are lots of different methods for factoring. I like to use a trial and error method personally, but I already have lots and lots of videos on the trial and error method, so maybe I'll show a different method. So a different method would be one method called the AC method. So with the AC method, you're going to take A, which is the coefficient of the squared term, and C, which is the coefficient of, well, I guess it's the constant term, and you multiply them together. So I'm going to do A times C, and A times C would give me 10 times negative 3, which is a negative 30. And I want to look for two numbers, and that pair of numbers needs to multiply to be negative 30, but those two numbers need to add to be the middle coefficient of b. So those numbers need to add up to be negative 2. So what I'm going to do is write down all of the factors of 30. So that's all of the possibilities for multiplying to be 30. And those possibilities are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And then I want to think about the middle number. So these are all the possible pairs that multiply to be 30. And I need to find a pair of numbers that will give me a negative 2. I'm not able to get that from adding or subtracting 1 and 30. I'm not able to get that from adding and subtracting a 2 and 15. It's not going to happen from 3 and 10, and it's not going to happen from 5 and 6. So what that tells me is that there are no pairs of numbers that satisfy what I'm looking for, and this quadratic equation cannot be factored. So since I couldn't find any pairs, this can't be factored, and instead I'm going to try the quadratic formula. Now the quadratic formula is a formula using a, b, and c, and that formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm going to substitute a, b, and c into this quadratic formula, and that would give negative 2 plus or minus negative 2 squared minus 4 times 10 times negative 3 all over 2 times 10. So then I'm going to start simplifying using order of operations. And I have a negative times a negative, that's a positive. Underneath the radical, I'll apply the exponent first. Negative 2 squared is 4. 4 times 10 is 40. 40 times 3 is 120, and that's going to be a positive 120. 2 times 10 is 20. Underneath the radical, I have 4 plus 120, that's 124. And then I want to simplify that radical. When you're simplifying the radical, you want to look for perfect squares that are a factor of 124. Now, if you don't know them off the top of your head, perfect squares, you can work them out. Perfect squares are 1 squared, which is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. We want a perfect square that will divide evenly into 124. So I have a calculator here. Let's see if I can get it to come up. Okay, there it is. And in 124, I'm going to divide that by the perfect square 4, and you can see that that goes 31 times. So 4 times 31 is 124. What you really want is the largest perfect square possible. And I know I've got the largest perfect square possible because 31 is a prime number. There are no other factors of 31 besides 1 and 31. So I know I've got the biggest perfect square that I could get. So underneath the radical, I'm going to change that to 4 times 31. And now I'm able to apply that square root to these factors individually. The square root of 4 is 2. The 31 is not a perfect square, so we can't simplify that anymore. And the final thing that we want to do to simplify this is a fraction, and fractions should be written in lowest terms. That means no common factors between the numerator and denominator. So I can see that these two numbers are even, which means that they have a factor of 2 in the numerator, and this number is even, so there's a factor of 2 in the denominator. So I can factor out the 2 from the numerator, and if I do that, I would have 1 plus or minus 1 square root of 31 over 20. Now this 1 here is unnecessary for writing because that's 1 times the square root of 31. And 2 and 20 have a common factor that I can divide out. So we can write this as 1 plus or minus the square root of 31 over 10. Now sometimes people will write this in one other format, and that would be as 2 separate fractions. If you did that, it would be 1 over 10 plus or minus square root of 31 over 10. So that's also correct. So this particular function has 2 x-intercepts, and the 2 x-intercepts are 1 plus square root of 31 over 10, comma 0, and 1 minus square root of 31 over 10, comma 0. So on this question, we are given this graph that's on the left, and we want to find the domain, the range, the intervals of increasing, decreasing constant, the relative minimum and relative maximum, and also the real zeros of the function. So let's start with the domain of the graph that we have on the left here. So we need to know the definition of domain. The domain is the set of all x's, the set of all first coordinates. And I like to use my ruler when I'm looking for the domain. And I hold that ruler vertically. You could hold your pencil vertically. And I hold it vertically like this for the domain because the ruler is pointing to different places along the x-axis. And since the domain consists of all the x's, that helps me identify the domain. So I'm going to start on the left. And the reason why I'm starting as far left as I can is that on the x scale, that would indicate the smaller values, the smallest values. And we're going to use interval notation, and interval notation is always written from smallest to largest. So as I go from left to right, the very first time that my ruler is hitting the graph is down here at this open circle. Now the open circle indicates that that point is not included, but that is where my domain starts. So I'm going to start it at an x of negative 10. So my domain will start at negative 10, and since that point is an open circle, 10 is not included in the domain, and I'll use a parenthesis to indicate that. So that's where my domain starts. If I go to the right, my ruler is touching the graph all along this part. So that means that all of these x values are included in the domain. All of the x values until you get to the end of the line, end of the curve, which is right here at an x value of 7. So that's when my interval notation will stop. And because that endpoint is a closed circle, that point is included in the domain, and we're going to use a bracket. So our domain consists of all the x values from negative 10 to 7, where negative 7 is not included, and negative 10 is not included, and 7 is. So that's our range, our domain. Now for the range is the set of all y's. So I'm going to hold my ruler horizontally and go from bottom to top, that's smallest to largest. The very first time my ruler hits the graph is right here at a y value of -5. So -5 is the start of my range. I'm going to go up, and all of these y values are included in the range since the ruler is touching the graph along these points. And it's not until we get to this spot right here that we have our last y value of 3. This is also a closed circle. Both the -5 and the 3 will have brackets on them because those points are included in the graph. So the next part is asking for intervals of increasing, decreasing, and constant. These words, increasing, decreasing, and constant, are describing y, but the intervals that we want to write down are x intervals. So first I'm going to identify the different pieces of the graph that are increasing, decreasing, and constant, and then we'll write down the intervals. So starting on the left, I'm going to trace the graph and observe the y values along this piece. Now let me pause 1 second here. I didn't mention this. As a part of the definition of increasing, decreasing, and constant, we always want to go from smallest to largest. So I'm starting as far left as I can so that I can start at the smallest x value. So as I trace, my y values are increasing, then decreasing, then increasing, then constant, increasing, and decreasing. So I'm going to label these different portions of the graph. We have increasing along this section, and this section, and this section. We have decreasing along this section, and this section, and we have constant here. So let me label that as constant, decreasing, increasing. And I want to write down the intervals of increasing, decreasing, and constant. Now remember, those intervals are x intervals. So I'm going to do the same thing that I did with the domain. I'm going to take my ruler and I'm going to hold it vertically because it's going to point to x values. So on this first interval, I labeled it increasing. That's going to start at an x of -10 and stop at an x of -8. Now, in our class, in this college algebra class, we have a source that is a textbook, and that textbook has defined our intervals to be open intervals. So this is coming from the definition in our textbook. When we have open intervals, that means that the endpoints are not going to be included in our interval notation. However, if you were to take my pre-calculus class, they have a different source, and that source defines the intervals as being allowed to be closed, so the endpoints could be included. So other sources might use brackets on this example, but for our class, when we write down intervals of increasing, decreasing, and constant, we're always going to use parentheses on the ends. So that was our first interval, from -10 to -8, and that was an increasing interval. Our next interval is a decreasing interval, which starts at an x of -8 and ends at an x of, looks like, -4. Notice I'm using parentheses again. Our next interval is an increasing interval, which starts at an x of -4 and ends at an x of -1. The next interval is a constant interval, which starts at an x of -1 and goes to 2, an x of 2. Then we have an increasing interval, which is 2 to 5, and then a decreasing interval from 5 to 7. Some sources will put the union symbol between these sets, and some sources will put commas between. I believe in my math lab they use commas between, but you'll want to make sure that you pay attention to the blue writing next to the blank, and it'll say whether to separate the intervals by commas or by some other means. So there we have the increasing, decreasing, and constant. So the next part says, for what values of x does f obtain a relative minimum? What are the relative minimum? And there are some different choices here that come from my math lab. We also have, in the next part, relative maximum that we're looking for as well. So we've got a definition from our book for relative minimum and relative maximum. A relative minimum can be found when you have a change from decreasing to increasing, and a relative maximum is going to occur when we have a change from increasing to decreasing. So we have those on our graph. Let me get a different color here. And on our graph right here, we have a point that creates a change from increasing to decreasing. We have a point here which changes from decreasing to increasing. And we have a point here which changes from increasing to decreasing. These are the locations of our relative minimum and relative maximum. Now notice that the question is worded in two parts. We have a part that asks, for what value of x does f obtain a relative maximum? Excuse me, that's minimum. So we have this one min here. This is a relative min. And it wants to know the x so that it occurs at an x of -4. And the second part is, what is that relative minimum? And that's the y part, which is -5. So the relative min itself is -5. In the second one, we have two relative maximums. One of them occurs, so these are the relative maxes. One occurs at an x of -8. It's obtained at an x of -8 and an x of 5. And what is that maximum? The relative max is the y part, which is 3, and the y part, which is 2. So this one has two relative maximums. So last question here. What are the real zeros of f, our function? The real zeros is just a name for the x-intercepts. It's another name for the x-intercepts. The reason why we call it 0, think about how you find the x-intercept. You find the x-intercept by setting y equal to 0. So when you're finding the zeros of a function, you're setting y equal to 0. The real zeros are the x-intercepts. An X-intercept is where the graph crosses or touches the x-axis. The x-axis is here. So we have several locations where the graph crosses or touches the x-axis. And we're going to write those down separated by commas, negative 19 over 2, negative 6, 3, 7. This is another thing you want to pay attention to, of whether you're supposed to write them as ordered pairs or how I've just written them here. Check it out in that blank next to the blue writing next to the blank. Okay, so here we have, this is almost like a continuation of the last example. However, the graph is a little bit different. So we have the graph on the left, and we want to answer these questions about the y-intercept. For what values of x is f of x less than or equal to 0? For how many values of x is f of x equal to negative 3? And what is the value of f of negative 2? So let's start with the y-intercept. A y-intercept is where the graph crosses or touches the y-axis. So we have the y-axis here. And we do have an intersection point. This point right here crosses the y-axis, and that point is 0, negative 1. So we have a y-intercept of 0, negative 1. Just pay attention to the writing in the blank or next to the blank about whether you're going to type negative 1 or you're going to type the ordered pair 0, negative 1. On the next part, we want to know for what values of x is f of x less than or equal to 0. Remember that f of x is the same thing as y. So this is really saying y is less than or equal to 0. For what values of x is y less than or equal to 0? So I've got my y scale highlighted in green there, and I just want to remind you that all of the points that are above the x-axis will have y being greater than 0. All of the points below the x-axis have y being less than 0. We know that from the y scale. And then right on top of the x-axis, that's when y is equal to 0. So we want to know when y is less than 0. That's going to be below the x-axis. And also when y is equal to 0, that's going to be on the x-axis. So let's highlight the points that are below. So that's these points here. Those are all the points with y values that are less than 0. And then we have some points that are on the x-axis. That's these points here that we want to include. And I want to know what values of x. So I want to write down, using interval notation, x values. So I can use my ruler again and think about when each one of these group of points start and stop. So this starts here with an x of negative 12. And that group of points stops at an x of negative 23 over 2. We do want to pay attention to whether we're including the endpoints or not. The endpoint here has an open circle, so we would not include that, and that would use a parenthesis to not include it in the set. However, the other end is on the x-axis, and it is a filled-in circle, so we want to include it. I'm writing in the wrong spot. Sorry about that. Negative 12 to negative 23 over 2. So then we want to look at our next line, next group. It starts at an x of -8 and will stop at an x of 1. Both of these points have a filled-in circle and are going to be included, so we'll use brackets. And then we have this point over here, which is on the x-axis, and it is a single point on its own. Interval notation requires a lower bound and an upper bound, so we're not going to use interval notation. We'll use our curly braces and just list that one point in the set. And we're going to union these sets together. So these are all of the x values on this graph that have a y being less than or equal to 0, or f of x less than or equal to 0. I'm going to erase my markings here and address the next part. The next part says, for how many values of x is f of x equal to -3? So remember that f of x is y. So let's read that question again with y. For how many values of x is y equal to -3? So let's identify all of the ordered pairs with y equal to -3. I'm going to draw a horizontal line at y equal to -3. This horizontal line shows me on the whole coordinate plane all of the ordered pairs that have a y coordinate of -3, and I want to find the ones that are on the graph. So starting over here on the left, I notice that this open circle crosses through that point with a y coordinate of -3, but we have to remember that the open circle is not included in the graph, so we're not going to include that one. Here we have a point that crosses the line y equals -3, but it's not labeled. And even though it's not labeled, it is part of the graph because it's on the line. So we are going to include that as one of our intersection points. And then we have this point here, which is labeled as -4, -3. So that's our second intersection point. So we have two values of x where y is equal to -3 on this graph. Our final points, our final part says, what is the value of f of -2? So that notation, f of -2, tells me that x is equal to -2. F of -2 is the y part. And so I'm looking for an ordered pair on this graph that has an x of -2. So I'm going to draw a vertical line at x equal -2. And that vertical line at x equal -2 shows me all of the ordered pairs on this graph, or on this coordinate plane, that have an x of -2. And this vertical line crosses the graph right here. That point is not labeled, but that point would be -2, -1. And so I know that f of -2 is equal to the y value of -1. All right, so here's another question that we want to work out from the practice test. It says, classify the given function as a polynomial function, a rational function, or a root function, and then find its domain. Write the domain in interval notation. We have the function g of t equals t plus 2 over t cubed plus 3t squared minus 10t. So first we want to classify it. And I didn't pull up the formal definitions for these three, but we'll do a very quick statement of what you can look out for. For the rational functions, you're looking for a variable in the denominator. For the root functions, you're looking for a variable to be underneath a radical. And for polynomials, you're looking to have x to a power, and that power needs to be a nice whole number, 0, 1, 2, 3, and so on. You should not have any radicals or variables in the denominator with polynomials. So we can see that we have the variable of t in the denominator, so we would classify this as a rational function. Then we want to find the domain of this function. So with rational functions, we have to pay attention to the restrictions. The fact that we have a variable in the denominator reminds us of what our restrictions are. Having a 0 in the denominator is something that is undefined. And this is what's going to cause us to have a restricted value. So we have variables in the denominator, so we need to figure out what the values of the variable will be to cause a 0 in the denominator. So we're going to take that denominator, t cubed plus 3t squared minus 10t, and we're going to set it equal to 0 to figure out what those restrictions are. Now this equation is what we call a polynomial equation or a cubic equation. There are lots of different methods for solving them, but in our class we're going to focus on the factoring method for solving these. So when you're factoring, your first thought should be, is there a common factor? And all three of these terms have t in it, so we can factor a common factor of t out, and that would be t times t squared plus 3t minus 10 equals 0. And then we want to continue factoring inside the parenthesis. Inside the parenthesis we have a quadratic. So I'm going to factor it into two binomials. The numbers that go in the front need to multiply to be your front term of t squared. The numbers that go in the back need to multiply to be your last term of negative 10. So we have t times t would give us t squared. And then I'm thinking of factors of 10. Factors of 10 are 1 times 10, 1 times 10, or 2 times 5. 2 and 5 could create the middle term of 3. So we're going to use the 2 and the 5. We want a positive on the 5 and a negative on the 2. And we have the correct factorization. You may want to double check here. So if I were to multiply this out, you would have t squared plus 5t minus 2t minus 10. And when you combine like terms in the middle, 5t minus 2t does give you 3t. So we did get it factored correctly. Once you get it factored correctly, you're going to use what's called the zero product property. And the zero product property, you set each factor equal to 0 and solve. So t equals 0 is solved. Here we'll add 2 to both sides. T equals 2. Subtract 5 on both sides and you get t equals negative 5. So these three values, 0, 2, and negative 5, if you substitute these values in for t, you will get 0. You will get a 0 in the denominator. A 0 in the denominator is undefined. So these values need to be excluded from the domain. So our domain is going to consist of the whole number line, negative infinity to infinity, but we're going to exclude the values of negative 5, 2, sorry, I should have listed 0 next, 0 and 2. everything else on the number line will be included except for those three numbers. So we're going to write our interval notation. This interval starts at -infinity and stops at -5. This interval starts at -5 and stops at 0. This interval starts at 0 and stops at 2. And this interval starts at 2 and goes to infinity. And we're going to use our set notation. We're going to union those together, and this is the domain. The domain is -infinity to -5, union with -5 to 0, union with 0 to 2, union with 2 to infinity. So for the following function, determine the difference quotient. The difference quotient is this expression here, f of x plus h minus f of x over h. And the function we want to calculate the difference quotient on is this one here, f of x equals x squared minus 4x. So I like to calculate the difference quotient in three parts. I start by calculating just this portion here first, and then I'm going to calculate the whole numerator, and then I'll calculate the whole difference quotient in the third step. So let's start with the first one, which is f of x plus h. So to calculate f of x plus h, we need to change these x's to x plus h. And that would give x plus h squared minus 4 times x plus h. So simplifying, we would get, I think I'm going to move my equal sign way over here because this is going to be a lot of terms. X plus h squared is x plus h times x plus h. Over here I can use the distributive property and get minus 4x minus 4h. I'm going to multiply out x plus h times x plus h, and that gives x squared plus xh plus xh plus h squared. I'm copying down the minus 4x and minus 4h. I do have some like terms here. xh and xh combine together to be 2xh. And other than that, I don't have any other like terms, so I'm just copying everything else down. So that is calculating just that piece of the difference quotient. But then I'm going to calculate the whole numerator, which is f of x plus h minus f of x. So I've already calculated that first part, the f of x plus h, so I'm just going to copy that down. That's x squared plus 2xh plus h squared minus 4x minus 4h. And then I need to append to that minus f of x. Well, f of x is this original function that was given to us. So I'm going to subtract f of x. So subtract x squared minus 4x. Notice I use parentheses. That's important because you want to make sure not to just subtract the first term, but to subtract the whole function. So I use the distributive property, and that gives all of this, which I'm just copying down, minus x squared plus 4x. And now I do have some like terms that I can cancel out. I have an x squared and a minus x squared. They cancel. And I have a minus 4x and a plus 4x. They cancel. So what's left is 2xh plus h squared minus 4h. And that's the whole numerator. So then finally, I'm going to do the whole difference quotient, which is f of x plus h minus f of x over h. So we just calculated that whole numerator. I'm going to copy it down into the numerator, 2xh plus plus h squared minus 4h over h. And you'll notice here that all of the terms in the numerator have an h in them. So I'm going to be able to factor out an h, be left with 2x plus h minus 4 over h, and those h's in the numerator and denominator cancel, and you're left with 2x plus h minus 4. And so we have a difference quotient of 2x plus h minus 4. Thank you for checking out my videos. Have a great day.